All right, we're going to go on to our next component of this unit where we're going to talk about hypothesis tests with two proportions. We have done just a hypothesis test with one proportion, but two proportions is actually more common than questions about isolated percentages. For example, is it true, is the true proportion of patients that have relief on medicine A significantly greater than the proportion of who experience relief with medicine B? See, you would have two separate proportions right there that you would be comparing to each other. You're not saying what that rate is, you're seeing if one is greater than the other. And it could be that one's the new medicine and one is the um, old, the current one on the market. Okay, how about this? Is the true proportion of women who say they frequently experience stress significantly different than the proportion of men who say they frequently experience stress? So we would take two separate samples and we would compare those two proportions. We are not stating where that proportion is located and how much that amount is. We're just seeing what's the comparison between the two. Okay, so you can either use there's the dogs, you can use a two proportion hypothesis test to determine if there's a significant difference in those proportions. So in AP statistics, we actually work on two proportion confidence intervals so we can estimate how much that difference is, but we will not get into that in this class. We'll just be working on, how are they related? Okay. Now, we are also not, will not do the computation for the z-score with our calculators because we won't do it by hand because it's a complex formula. I do not even have my AP statistics students do that. They're not necessarily needed to do that. They can use technology. However, you have to have a TI-84, our small classroom TI-80, TI-39s, or whatever those are, the little gray ones. They do not have that ability to do a two proportion z-test. So therefore, I'm going to give you the z-score, and then you're going to compute the p-value. And so then our focus of the lesson will be on the interpretation and the conclusions that you make from those results. All right, here we go. So we wonder, okay, so maybe you're going to have a job later where you're working in a community and you wonder if being part of a support group that meets regularly help people who are wearing a nicotine patch actually quit smoking. A county health department tries an experiment using several hundred volunteers who were planning to use the nicotine patch to help them quit smoking. Okay, so the quality of our volunteers, they already were motivated to quit. And number two, they were all planning on using the nicotine patch. So they are now wondering if the addition of the counseling group will make it a higher success rate at quitting smoking. The subjects were randomly divided into two groups. People in group 1 were given a patch and attended a weekly discussion meeting with counselors and others who were trying to quit smoking. People in group 2 also used the patch, but they did not participate in the counseling groups. After 6 months, here are the results. 46 of the 143 smokers in Group 1 and 30 of the 151 smokers in Group 2 had successfully stopped smoking. Do these results suggest that such support groups could be an effective way to help people stop smoking? So we want a yes/no answer as to, is this significantly better than the other thing? So we have two groups, two proportions. So we have to define two parameters, both of them. It's helpful to use meaningful subscripts like P and with the W for proportion of women and P with an M for proportion of men. So use meaningful subscripts so you can keep track of what you're talking about. Remember, when you write your parameters, they need to be in present or future tense We are not inferring about the sample that has happened in the past. We are making an inference about the now or in the future. All right, so here's an example of what these parameters would be like. I did P with a little c. For the proportion of people, I should probably say proportion of smokers who wear the nicotine patch and also attend counseling that successfully quit smoking. Do not leave that part out. We're not just saying, hey, what proportion of people wear a nicotine patch and attend counseling? No, that's not what we're doing. We're seeing of those people who wear a patch and attend counseling, what proportion of them actually quit smoking? All right. P of P, so I put the little subscript P, is the proportion of smokers who wear nicotine patch only and successfully quit smoking. Don't leave off that successfully quit smoking because that's your numerator. All right. So how would our hypotheses statements look? The null hypothesis, remember, is always the same. So we start off saying, hey, they have the same success rate. So HO, I'm going to set the proportion for the counseling equal to the proportion with the patch only. So the success rate's the same. But we were wondering if the counseling has a higher success rate. So my HA says proportion of those on the counseling who quit smoking is greater than the proportion with patch only who quit smoking. Okay, so do you remember that from what we did before in our unit where the HO is the always equal to, the HA is the one that's the, you have a different sign depending on what you're investigating and what you are wondering. Alrighty then, so now I'm giving you the z-score, okay, because that's one that's pretty intense formula there, and we're not doing that. And I don't have the calculators for you all to put that in and run the test in the calculator. So instead, I'm giving you the z-score, and then you're going to norm CDF. Now, why did I go to positive 99? Well, that's because my alternative sign went greater than. So I want to know above 2.41. So I norm CDF'd that, and that gave me 0.0080. So that's a small p-value. So do you remember what happens with a small p-value? Let's see. If the p-value is low, reject HO. P-value is low. Reject HO. The null hypothesis has to go. So we will say our p-value is less than alpha of 0.05. Okay, so remember that's the default alpha if we are not told a different significance level. So I'm going to go over here real quick and see where we told a different significance level. That's the words it'll use. That's the language. Significance level is a different alpha. Okay, I don't see a different significance level. All right, so then we will use the default of 0.05, and our p-value is definitely smaller than that. So if that p-value is low, what decision will we make? The null hypothesis has to go. So we're going to reject HO. All right, so remember that if we have HO and then we have our HA, if we reject HO, then we do have evidence to say HA is true. Okay, we can say HA is true. I mean, we have evidence to support HA. Okay, I can't say HO is true or whatever, but so here we go. There is evidence that the proportion of people who wear the nicotine patch and go to counseling quit smoking at a higher rate than smokers on the nicotine patch alone. All right, very good. Then I take you through what we have just come from. Type 1 and Type 2 errors and the consequences of those. See how we just keep tacking it all on together. It's all one huge process that began at the beginning of the school year whenever we started taking samples and the proper way to take samples. All right. So here we have type 1 error. The null is true, but we rejected it. We made an error. So let's see. The null is true. That would mean The patch and counseling treatment is the same effectiveness, but we rejected it and we think counseling works. So what could happen? Consequence, we might waste money on counseling that isn't a significant improvement to helping people quit smoking. All right, how about type 2? Okay, that's HA is true. HA is true. So that means that we think that the counseling is working. Okay? I mean, no, wait. The reality is HA is true. That's reality. So the counseling is helping, but we did not detect it. We failed to reject the false null hypothesis. The counseling increases the quitting smoking success, but our sample did not detect that it makes a difference. So we miss out on the opportunity to help people quit smoking. Alrighty then, there's that problem. And so now I want you to pause your this video, and I want you to try this second one completely on your own. Okay? And so then I will have a second video of me going over this next problem, and we'll see how you do on all of that. So stop this video now, try the next one completely on your own, and we'll see how you do.